All right, Algebra 1B students, welcome to part 1 of lesson 7-6. We're going to start looking tonight at exponential functions. So turn with me please to page 453 of your books, and we're going to start there in just a minute. But before we do, I want to warm up with this warm-up problem where we're going to make a table where we continue to multiply 2 by itself over and over and over again. So we're going to multiply 2 times itself a certain number of times and get an answer. That's going to be our y number. Okay? So y is going to equal 2 times itself some number of times. So for example, when x is 2, that means this is going to be 2 to the second power, 2 times 2, which gives us 4. All right, so if we look at this table, when x is 1, 2 to the first power we know is just 2. When x is 2, 2 to the second power we know is 4. When x is 3, I'm going to have 2 to the third power, 2 to the third power, which equals 8. All right. When I have x equals 4, I have 2 to the fourth power, which is going to equal 16. 2 to the fifth power when x equals 5 is going to give me 32. And 2 to the sixth power when x equals 6 is going to give me 64. All right? So this table that we've just created of multiplying 2 over and over and over again a certain number of times, whether it be 2, 3, 4, 5, 6, or however many you want, is an example of an exponential function, which is what this section is all about. So look with me at the bottom of page 453, and you should see this key concept box about exponential functions. Right? And it tells us that an exponential function is a function in the form y equals a times b to the x. Right? So a is just some number, and then we have another number to the x power. And this is the important part when we talk about exponential functions. All right? Some number needs to have an x or some other variable in the exponent. All right? So we've been dealing with a lot of exponents so far in this chapter, but they've all been numbers. Now in this section, we're finally going to get to variables being in our exponents. All right? And you can see a few examples here of the way graphs of these look. And we'll deal with the graphs of them in our video tomorrow/Wednesday night. All right? So here's a couple examples for you to look at. This expression here is y equals 2 to the x power. This one that goes down is actually y to the y equals negative 2 to the x power. And then you can see a couple here with fractions to the x power. And they look different because they actually come down and level out instead of being level and then shooting up or shooting down like we see over here. All right? So that's an exponential function, and our job for today is just to be able to identify them and to evaluate them. So again, the key thing that we're looking for is right here, some number to the x power. All right? So flip with me to page 454, and we will look at this example where they ask us to identify an exponential function based on a table, right? The other option for us is a linear function, and we'll talk about the difference now. Okay? If we look at our table, we can see that our x values from 0 to 1, 1 to 2, and 2 to 3 are just going up by 1 every time, like they say right here. Right? We're just adding 1 every time to our x, which is what we would expect. 0, 1, 2, 3, just like we had in our warm-up table. Right? But our y values are a little different in this table. Right? They, to go from -1 to -3, -3 to -9, -9 to -27, we're actually timesing these by 3 every time, right? Like they say down here. So we're not adding some number every time. Instead, we're actually multiplying by some number every time to get to our next y value. Okay? whenever we see timesing or multiplication right here, that indicates that this is an exponential function and not a linear function, okay? So this one, this table definitely does represent an exponential function. Exponential function. And again, it is because we see this multiplication pattern in our y values and not an addition pattern like we see in our x values, okay? Let's look at one more example. This equation right here, y equals 3 to the x. The question that they're asking us here is that a linear or an exponential equation? Okay. Now, as I said on the in the key concept box on the last page, the thing we're looking for exponential functions is an x or a variable in the exponent of a number. So something like 3 to the x power would be an exponential function, but that's not what we have here. Right? That's not what we have. So this function is not an exponential function. And if we make a table of it, we should be able to see that this is not an exponential function. Right? So I'll just do a few quick examples of x and then our y outputs here. Let's do the same ones that we did up here. 0, 1, 2, 3. Now, if I plug each of those x values into my equation, 0 in for x is 3 times 0, which is 0. 1 in for x is going to give me 3. 2 in for x is going to be 3 times 2, which is 6. And then 3 in for x is going to give me 9. All right? And what I want you to notice here is to go from one x value to another, I am adding 1, plus 1 more, plus 1 more, right? To go from y value to y value, I'm doing something very, very similar, but to go from 0 to 3 to 6 to 9, I'm not adding 1 anymore, I'm actually adding 3. Plus 3, plus 3, plus 3, right? So because this is a plus or a multiplication pattern, right, this is a plus 3, whereas up here in our exponential example, it was times, okay? So if in the table you see a plus pattern in your y values, that is a linear equation. If you see a multiplication pattern, like we did up here, that is an exponential function. All right? Your job now is to take a look at got it, number 1, right in the middle there, page 454. Page 454. Take a look at these two problems. It's a table and an equation, and I would like you to take a look at those two and decide, is one of them linear or exponential? Well, actually both. For A and B, is it linear or exponential based on what we've just talked about exponential functions, right? So pause the video, take a look at those two problems. When you're ready, come with me to the next slide, and we will look at how to evaluate an exponential function, which is really quite similar if we use our calculator, which we will. All right. The only other thing that we need to do for this practice problem set is to be able to evaluate exponential functions for a certain x value. All right? Now, I've actually screwed this problem up a little bit, which I apologize for. But let's read through it, and then we will look at how we evaluate this function right here, this function, for a certain number x. So it says we have 30 flower beetles that are left undisturbed in a warehouse bin. The beetle population doubles every week, which is the part that I missed, doubles every week. The function 30 times 2 to the x power gives the population after x weeks, right? X weeks. How many beetles will there be after 56 days? Now, you can forget about all of this, because that is not correct. But what we do know is that we need to figure out how many weeks we're going to leave the beetles there so that we can plug that number into our exponent x. All right, so 56 days equals how many weeks? Well, there's 7 days in a week, so, or sorry, 7 days in a week. So 56 divided by 7 equals 8 weeks. Right? 8 weeks. So x weeks is in my expression right here, 2 to the x, and they tell me that the x is the number of weeks. So instead of saying 30 times 2 to the x, for this evaluation, I actually want to say 30 times 2 to the 8. I'm just taking my 8 and putting it in where the x is. Right? So this is really 30 times 2 to the 8th power. Okay, if you did on your calculator 2 to the 8th power, it would be 256. So we really have 30 times 256. And if we do that multiplication on our calculator, our answer is 7,680 beetles. And so all I did was figure out what number they wanted me to put in for the x, right here, and I plugged it in 8 weeks in for x, and then I just did some calculator work from here. Right? So you can check that, please, on your calculator, that 2 to the 8th is 256, and that 30 times 256 gives me 7,680. The only other thing I want to point out, to make you aware of, and be careful of, please, is that when we get to right here, it can be tempting for some students to say 60 to the 8th power. Because 30 times 2 is 60, and we're taking it to the 8th power. But we are not taking the 30 to the 8th power, only the 2 is going to the 8th power. So this is wrong. Please do not multiply the numbers until after you have dealt with the exponents. All right? Hopefully that will alleviate that misconception, and we won't have to worry about that moving forward. Right? Your job before our practice problem set is this problem right here. Got it, number 2, at the very bottom of page 454. This is still page 454. All right. Now this one is interesting because we're talking about x half-year periods. Right? Because our rabbit numbers triple every half of a year. So in 3 years, hopefully you can figure out that there are 6 half years. Right? 6 half years. So the number that they want you to put in for x there is 6. So go ahead and do that. Evaluate this function here when x is 6 half-year periods. And then once you've mastered that problem, the art of plugging in and solving on your calculator that exponential function, you are ready for your practice problem set. If anything that I've done so far doesn't make sense, please make a note to ask me in class tomorrow. Otherwise, you are all set. That's all I have for you tonight. Have a wonderful night.